Welcome to Unite Now, where we bring unity to you, wherever you are.
Welcome to the Physics Playground Prototype, a way to get started experimenting with physics in Unity. This video is part of our beginner prototype series, in which we explore creating small projects focused on game mechanics. We wanted to create a prototype that allowed players to experiment with Unity's physics system, which allows you to create a lot of complex gameplay with a few simple elements. In order to do this, we decided to create a camera that can fly around the playground room and allow the player to click with the left mouse to spawn objects and also use the shift click to destroy them. We also decided to make it possible in the project to change gravity, freeze the physics of objects at any time, go into slow motion, and more. This allows players to really experiment with a lot of the crazy stuff that you can do with time and physics in Unity in a fun way. Here's a quick overview of what we will look at in this video. The camera and how we move and control it, the object spawning and despawning system, how we're managing physics, and our explosive bomb objects. In later videos, we'll explore the physics and gravity effects and how we added effects and polish to the prototype. Let's start by looking at our camera. We knew we wanted to have a free-flying camera to allow players to navigate the scene and place objects in a flexible way. The camera represents the viewer's perception of our scene. Setting up a camera properly can be very complex. For this reason, Unity comes with a powerful tool called Cinemachine. This can be found in the package manager and comes with different camera setups ready to be used. For example, a Cinemachine free-look camera is perfect for third-person camera experiences. It orbits around 3 customizable rigs, giving the possibility to explore and move around a target using the mouse without writing any additional code. In this project, we wanted to move the camera the way that you can move it in the scene view of the Unity editor. In the scene view, it is possible to move and rotate the camera's position by holding down the right mouse button and pressing the W, A, S, and D keys. To achieve this, we used an empty Cinemachine virtual camera and added our sample camera controller script attached to it. This is based on a script which you can find in the script folders of any new empty Unity project that uses one of Unity's provided templates. A Cinemachine virtual camera comes with many possible extensions. These extensions provide useful additions to the camera's behavior. For example, the Cinemachine confiner limits the camera's position to an area of our scene. The Cinemachine impulse listener generates and manages camera shake reacting to game events. We decided to use both of these in our prototype. Since we're using a free-flying camera, we chose to use the confiner to prevent players from flying the camera out of the play area. We decided to use the impulse listener to shake the camera when explosions happen. This makes the explosions feel powerful and the prototype feel more exciting. We wanted to create a system to allow players to spawn and despawn objects. We decided to do this by allowing them to spawn by clicking with the left mouse and to despawn using shift click. We first tried using right click, but realized that we needed the right click to be used by the camera's movement, and so decided that shift click would be a good choice for deleting, since it's something players will do less often. This means that clicking with the left mouse button instantiates a new object in the scene. To instantiate in this context means to copy an object in our world while the game is running. You will also hear people talking about spawning or creating objects, which means the same thing. The idea for this prototype is for players to have fun instantiating objects while physics is frozen, and when they're done doing that, turning the physics on to see what happens. When we instantiate an object, usually we do it based on something called a prefab. A prefab can be thought of as a template for an object which has been assembled previously and then saved. If you want to, you can create complex shapes by combining different 3D objects into a single prefab. For instance, This castle is composed of several prefabs nested under a single parent game object, allowing us to spawn them all together with one click. With the keyboard keys V and B, we allow players to cycle through the spawnable objects while the game is running. To show the player what they are about to place, we position a ghost object with a special outline material in the world as a placeholder for where their new object will be spawned when they click. While we were designing the system, we also added a line extending down from the marker to show what it was going to be placed on top of, since sometimes visualizing what something is above in a 3D view, it's not easy. The marker displays objects are instantiated at the beginning of the game and then turned off, except the first visible object. When possible, it's good to reuse game objects instead of spawning new ones. This is because enabling or disabling game objects is more efficient than instantiating a new copy every time. We designed the spawner script to make it easy to add new prefabs for the player to spawn. If you would like to add your own new spawnable objects, you can find the objects list in the spawner script attached to the manager's game object, and you can drag your own prefabs into it. When adding new objects, we want to make sure that each prefab has a rigid body component and a collider component attached to it in order for it to be affected by physics and used by our manager scripts. We'll talk a bit more about what these components do later in the video. We also added functionality to the spawner script to allow players to delete or destroy objects by holding down Shift and left clicking. This allows them to clear space or allow players to play around with removing objects while physics are turned on and seeing if things fall over. In this prototype, physics are really at the heart of gameplay. We wanted players to be able to go back and forth between physics and no physics mode, in a way that was somewhat similar to the way you go in and out of the play mode in a Unity editor. With the space button, we can switch between physics on and physics off modes. These are represented by the play and pause icons in our in-game UI in the lower left hand corner of the game view. We realized while we were working on the prototype that it wasn't always clear what modes were on or off, and so we added a number of features to try to make it as clear as possible what state the game was in, including this UI. In the physics on mode, objects are affected by physics. This happens because each object has a rigid body component attached to it. This component lets Unity's physics engine control the object's motion, pulling it downward with gravity and reacting to collisions with other objects if a collider component is attached to each of them. The fun thing about making games that use physics is that the physics engine will handle all of these calculations for you, making it an easy type of gameplay to get started designing. When we play our scene and activate physics on mode, objects fall to the ground, collide with each other, and even react to explosions. The physics off mode is the opposite. In this mode, objects are not affected by physics even though they do have a rigid body component attached to them. This is possible thanks to the isKinematic property of the rigid body component. If isKinematic is enabled, forces, collisions, or joints will not affect the rigid body anymore. In other words, a kinematic object remains still in the position and it's not moved or rotated by physics forces. It does, however, continue to affect other objects that collide with it due to its attached collider. Colliders are invisible elements that enable physical collisions. If you ever run into an impassable, invisible wall in a video game, you have encountered a collider. In most cases, colliders match the visual shape of an object's mesh. The mesh of an object is a 3D geometry which allows it to be rendered on screen. This means that objects which have meshes but not colliders and rigid bodies are like ghosts. We can see them, but they don't collide with other objects, nor are they affected by forces. Our placeholder object that we are using as a marker to decide where to spawn things doesn't have a collider or rigid body, and this means that we can move it whatever we want without affecting placed elements. The way that all of this is coming together in our scene is that we are using our spawn object manager script to turn the isKinematic property of spawn objects in our scene on and off when the physics modes change because the player pressed the button, by default the spacebar. To make things more interesting, we created an explosive component. Attaching this component on a spawnable object makes it very dangerous. On the first collision with another element in the scene, the explosive object starts blinking, and after that, it explodes, pushing away nearby objects. This type of bomb that explodes when it's touched, it's something that we've seen in a number of physics games, and makes the gameplay more interesting because it creates a kind of chain reaction effect when something falls on top of it or it falls over. The explosive component is configurable, and you can set many of its properties like explosion power, radius, and countdown time. We will be continuing to explore the physics playground prototype in upcoming videos, including a video on how we set up the slow motion and reverse gravity effects, and another video on how we polish the prototype including post-processing, particles, and audio. The physics playground is available to download for free via the link in the description. If you are interested in digging more deeply into the concept shown, we've also recorded a slightly longer workshop video which is published on the Unity Learn website. You can find a link to that in the description as well. Hopefully this has given you some ideas for how to use some of these tools and techniques in your own games. Thanks for watching.